we'll be talking about the timing consideration. Timing consideration is very important when considered to the response of the input or to for the triggering of the input or maybe the output response for the input change. Okay, so timing consideration when considered for a flip-flop or a latches, it is very important. Okay, so when we are using a flip-flop, the following information is needed to be considered. So propagation delay. What is the propagation delay? The propagation delay is the time difference between the application of the input to the occurrence of the output. I repeat once again. What do you mean by propagation delay? The time difference between the application of an input and to the occurrence of the output is known as propagation delay. The propagation delay may be from when the input is changing from low to high, or maybe the propagation delay time changing from high to low. So TPLH, that is the propagation delay time when the signal is moving from logic 0 to logic 1, that is low to high. TPHL means the propagation time the signal is moving from high to low or from logic 1 to logic 0. The time needed for an input signal to produce at an output signal, that is known as propagation delay. That is the time taken by the input to the time difference, that is from the application of the input to the occurrence of the output is known as propagation delay. Next, minimum pulse width. W stands for width. Minimum stands for MIN stands for minimum. Minimum pulse width, which should be the minimum width criteria for the application of the any signal for the desirable output. If this much minimum width is not applied to the system, then desirable outputs will not be occurred. Okay, so this is the minimum width criteria for any signal for having at the output desired output. Okay, minimum amount of time a signal must be applied. This is the minimum time required for a signal should be applied at the system. If this much width if you didn't apply, then you will not get the desirable outcomes at the output. Okay, so metastable state or undesirable forbidden state will be there if you do not apply this minimum pulse width time. Okay, setup time and hold time. TSU, TH. SU stands for setup time. H stands for hold time. Setup time of the clock before it is applied to the system. Hold time when the clock is applied, when the input is also applied, the output should be latched for certain period of time. That is, the data should be holded for certain amount of time, that is known as hold time. Okay, setup time is before applying the clock. Hold time is after the signal is getting latched. Okay, minimum time the input signal must be held fixed, setup time before only, that is before application of the clock setup time, and after the latching action is the hold time. Okay. So next we have propagation delays in a SR latch. We have already learned SR latch. We are seeing here when S is 1, it will set the SR latch. You can see here when R is 1, okay, it will reset the latch. So we are going to consider here when S is 1 and when R is 1. So students, you can see here we are considering the midpoints. Okay, here is also midpoint of this. This is known as rise time. What is this? From going from logic 0 to logic 1, it is rise time. from logic 1 to logic 0 is a fall time. This is the rise time and this is the fall time. Okay. So when S is 1 now, here we have, here S is 1, R is 0. Okay. Here it is trying to change to from logic 0 to logic 1. So midpoints we have considered, this is the TPLH, means propagation delay time when the output is changing from logic 0 to logic 1. Okay. So next, when S is 1, it will be the set. Q is in the set state. That is, we are latching out 1. We are latching the 1 into the Q signal. So here 1 is there. Okay. Next, when R becomes 1, that time Q should be reset. That is, logic 0 will be latched in this. So TPHL, that is the propagation delay time when the output signal is moving from logic 1 to logic 0. Similarly, Q and Q bar are complement to each other. Q and Q bar are complement to each other. What you understood from this slide is, when S is 1, Q is being set with a particular amount of propagation delay, and that delay is specified by the manufacturer itself. Okay. Q and Q bar are complement to each other. When S is 1, Q is set with appropriate delay. When R is 1, Q is reset with appropriate propagation delay. What do you mean by propagation delay? Propagation delay is the time difference between the application of the input to the occurrence of the output. That is a propagation delay. Immediately when input change, instantaneously the output will not change. It will take some time. It will take some delay. That amount of delay is propagation delay. Okay. Propagation delay, two types, TPLH and TPHL. When the signal is growing from low to high, TPLH. When the signal is growing from high to low, it is TPHL. Okay. Next, so with this propagation delay with having some content, we have to draw the timing diagram. Students, timing diagram is very important. Whenever if I ask you, let me talk about this timing diagram for an SR latch. Students, we all know that S is set, R is 0, means Q is set. Okay. Next, coming to this, S is 0, R is 1, it is reset. Next, coming to this, S is 1, R is 0, so it will be set. Okay. So here when S is 1 here, R is 1 here, both are 0. You can see it is a metastable state or unpredictable state. When in SR latch, if S is 1, R is 1, both the output return to 0 simultaneously, it is an unpredictable behavior. Either S should be 1 or R should be 1. Both should not be 1 together. Otherwise, it will reach the forbidden state or unpredictable behavior. Next, here S is 0, R is 0. Okay, so it will retain the earlier state. Okay, next you can see here at t15 instant of time, both are returning to 0 at the simultaneously. So the Q is not coming to know which state it should be there, because S and 0 are returning to 0 at simultaneously. So at this point of time, the latch does not know whether it should be in the latch 0 state, or it should be in the latch 1 state, or it should be in the metastable state. So now when suddenly the S becomes 1 here at this time, okay, so it will try to go in the set state here. Okay, until and unless when both are 0, it does not simultaneously both changes to 0. It may be in logic 0 state or logic 1 state. Okay, maybe in the set state, maybe in the reset state. Okay, and suddenly when the R becomes 1 here, Q becomes 1, Q bar becomes 0. S is equal to 1 means it will set the latch. Okay, R is equal to 1 means R is equal to 1. Okay, here it will reset. You can see the first two states if we want. At time instant t1, S is 1, Q is 1. At time instant t3, R is 1, Q is 0. It is in the reset state. It is in the reset state. So this is a timing diagram for an SR latch. What all you have to draw in the timing diagram is draw the S input line, R input line, Q output line, Q bar output line. S and R are the set inputs and reset inputs. If S is 1, SR latch will be in the set state. If R is 1, SR latch will be in the reset state. Q and Q bar are complement to each other. Minimum pulse width constraint. This is the TW minimum. MIN stands for minimum. TW stands for width. Okay. These input signals are there, no? They should be in 1 for certain amount of time. Then only you will get the desired output. If suppose S is not stable before this time period, if it changes to 0 here only, if S changes to 0 here only, you will have undesirable consequences. So there is certain criteria for the input signals to maintain certain width. Width means certain amount of time it should be at logic 1, then only you will get the desired output. Certain amount of time if it's not at logic 1, then you will not get the desired output. So you have to maintain some pulse width for the S and R signals to have desired outputs. So next we have timing diagram for a gated D latch. Gated D latch. Yes.
Some are trying to join.
So I was talking about the timing diagram for a gated D latch. So gated D latch is a transparent latch. Whenever D is 1, okay, output will not change up till the clock signal is 1 or a control signal is 1. If control signal is 0, whatever changes may be happened in D input, it is ignored. That is, ignored means it will not reflect at the output side. Okay. Now check. Whenever the clock signal is 1, D is 1, the output is 1. Okay. So it will retain up till the next clock signal becomes 1. Now again, when clock is 1, D is 0, the output is 0. See, whenever the clock signal is 1, the data is 0. Immediately it will not become 0. It requires some time. That is known as propagation delay time. The time difference between the application of the input and to the occurrence at the output, that is the propagation delay. So it will hold up till the next clock signal becomes 1. Okay, when clock becomes 1, D is 1, so it will retain the E state. Now you can see here clock is 1, D is 0, again Q output becomes 0. So whenever the clock is 1, if there are any changes in the D input, then it will reflect on the output. Okay. So when now again it will retain up till the next clock signal. So next clock signal is 1 here, and here it is 1. So earlier also it was 1, now also it is 1. Okay. And next you can see here, this is a setup time. The clock becomes 1 to 0. This is a setup time before application of the clock signal. Hold time is after the latching action has occurred. Setup time and hold time. So here master slave SR flip flop. There are two sections in this master slave SR flip flop. You can see here the logic network for the master slave SR flip flop. Two sections are there. This is the master section and this is the slave section. Okay. Each capable of storing a binary symbol. It can store 1 or it can also store 0. The first section is referred to as master. This is referred to as master. And the second section is referred to as slave. This is a master and this is slave. So it is constructed using SR latch. You can see the master is an SR latch. Slave is also an SR latch. Okay. The information is entered into the master on one edge or level of a control signal, and then the information which is stored in the master, it is transferred to the slave on the next edge or level of the control signal. Each section is a latch. So master is a latch, slave is also a latch. Whatever the information is there in the master, it is transferred to the slave on the next edge or on the next level of the control signal. Okay, so how to draw this? First you draw an SR latch here, master. Next you draw an SR latch here, slave. Then you apply the inputs S and R and the clock. The clock has been connected to the inverter. The inverter output is connected as a clock to the slave section. Okay, so for the master we have two outputs, QM, QM bar. For the slave we have two outputs, QS, QS bar, and these are the Q and Q bar outputs of the master slave flip flop. S and R being the inputs of the master slave flip flop, Q and Q bar being the output of the master slave flip flop. Okay, the output changes occurs only on the next edge or on the level of the control signal. These are known as pulse triggered or the level triggered flip flops. So here master slave SR flip flop, you can see this master slave SR flip flop, master section and the slave section. Whatever the data is present in the master, it is transferred to the slave, okay, on the next level of the clock pulse. So here you can see, students, whenever C is 0, that is this C is 0, if this is 0, master, this SR latch is disabled. If C is 0, any changes on the S and R are ignored. Okay. So now if C is 0, this one, so this 0 will go here and this becomes 1, isn't it? So this 1 will be applied as a clock to this slave. So slave becomes enabled here, right? So now when it is 0, this clock is 0, the master is disabled. Any changes on the S and R is ignored. Okay, slave is enabled. Is the same state as the master. Slave is enabled and it will retain the same state as it was in the earlier. Okay. Next, when C becomes 1, what happens? So C becomes 1 here. Slave is disabled. If C is 1 here, this becomes 0. This 0 is applied as a clock to this slave. So when C is 0, this slave section is disabled. It retains the same state of the master. Okay. Now C is 1, master is enabled. Response to the input. Whenever C is 1, the changes in the SR reflect on the output of the master. Okay. So whenever C is 1, S and R changes, immediately it will change on the QM output. So whenever C is 1, slave is disabled, master is enabled. Response to the inputs S and R, changes in state of master are not reflected in disabled slave. Okay. So what he is trying to tell is, C is 1 here. What happens? Whenever change in the SR, it will reflect on Q and QM bar. QM and QM bar. If this is 1, what happens? There is an inverter connected. No, because of this inverter connected, if this is 1 here and 0 here, this 0 will be applied to this C. So slave section is disabled. So whatever changes may happen in the master, it will not reflect to the slave when C is 1. Okay. Next, again when C becomes 0, master is disabled. Slave is enabled, and it takes on to the new state of the master. So when clock was 1, this is enabled, no, it will take to a new state. So the new state will be at the QM bar output. Clock was 1, this was disabled. Now when clock becomes 0, this becomes 1. So whatever the new state was there on the QM, it will be reflected on the QS and QS bar. Okay. So important for short periods during rising and falling edges, both master and slave are disabled. Okay. For some time both are disabled, and that is undesirable and it should be avoided. Okay. So here you can see here S and R, Q and Q bar. This is the master section. This is the slave section. Okay. Whenever you can see here time instant T1. What happens? This is the clock signal. Observe carefully, students, here. This is the clock section. When a clock is 0, what happens? See here. When clock is 0, this is master is disabled. So it is written here. Master is disabled. Clock is 0, master is disabled. Because of this inverter presence, clock is 0, here this is 1 is applied to the clock, slave is enabled. Slave is enabled when clock is 0. So next coming to this, T1 to T2 both are disabled. This is undesirable. Okay, from T2 what happens? Clock is 1 up till T3 clock is 1. So clock is 1 means this is enabled, master is enabled, slave is disabled. Next again clock becomes from 1 to 0. Okay, from T3 to T4 both master and slave are disabled in this section. In this section both are disabled. Okay, next from T4 clock becomes a 0 again. Clock becomes a 0. So if clock becomes a 0, master is disabled, slave is enabled. Okay, so both are mutually exclusive. Whenever clock is 1, master enabled, slave disabled. Whenever clock is 0, master disabled, slave enabled. Okay, so it is written here, whenever master is disabled, slave enabled. When clock is 1, master enabled, slave disabled. When clock is 0, slave enabled, master disabled. Okay. Next, what is this function table of the master slave SR flip-flop? These are inputs given. S, R, C. What is this? It's a clock pulse applied. Outputs Q plus bar. Okay. Whenever SRR 00 clock pulse is applied, it retains the present state or a current state. Whenever S is 0, R is 1, clock pulse is applied, it will reset the master slave SR flip-flop. Whenever 1 is 0, S is 1, R is 0, clock pulse is applied, okay, it will set the master slave. When both are 1 1, it is undefined state. Okay, here it is undefined state. Irrespective of the cross mark means whether SR is 0 or 1. If clock is not applied, it will retain the current state only. Okay, these are the symbols. Symbol of the master slave flip flop. What is this? This is known as postponed indicator. Postponed indicator. So this is the network. This is the clock signal going from 0 to 1. It will retain 1 from 1 to 0 again. Next, this is the function table. This is the symbol. It says that if S and R is equal to 1, when control signal goes from high to low, we are in an unpredictable state, can cause a metastable state. Metastable state means neither it is at logic 0, neither it is at logic 1. It is in between. It is unpredictable state. So this one is explained. If S is 1, R is 1, clock is applied, but the output are in undefined state. So slave only takes on state of the master at T4. Okay. So from here to here, from T3 to T4, both are disabled. Slave will take the state of the master at T4. Okay, in between it will not take. At time instant T4, whatever the data is in the master, it is copied into the slave at time instant T4. Now what is this pulse signal? Pulse symbol indicates master enabled when C is equal to 1 and state of the master is transferred to the slave at the end of the pulse period. Okay, whatever the content is there in master, that will be obviously copied into the slave on the next edge or on the next level of the clock or a control signal. Control signal is a clock only, C. Okay. So here what you have to understand is whenever the clock is 0, master disabled, slave enabled. Whenever clock is 1, master enabled, slave disabled. Okay. So now assuming clock is 1, okay, clock is 1, whatever may be the inputs on the R, master enabled, slave disabled, so that it will that output will reflect on Q and QM bar and it will hold that data. Next, when the clock becomes 0, okay, master will hold the current state and this becomes 1. When clock is 0, no, it will hold the same state, it will not change. So 0 will come here at the input of the inverter, 1 will come here. So 1 will come at the C of the slave section. So slave is enabled now. Whatever the QM and QM bar are there, they are applied to the S and R inputs of the slave section. That input, whatever was on the QM and QM bar, are applied to the S and R of the slave section and it will reflect on QS and QS bar on the next level of the clock pulse. Okay, so what you have to understand here is that whatever the content of the master will be copied onto the slave on the next edge or on the next level of the clock pulse. So here this postponed output, what is this? This symbol is postponed output indicator. Output change postponed until the end of the pulse. Next, timing diagram for master slave SR flip flop. So here we have S, we have a R input, we have a C input, we have QM output, that is master output, QM bar, okay, master output in the complement form, QS, slave output, QS bar, slave output in the complement form. QS is nothing but a Q output of the master slave SR flip flop. QS bar is the Q bar output of the master slave SR flip flop. This is how we have to draw the timing diagram for the master slave SR flip flop. Whenever S is 1, R is 0, clock is 1, okay, it will set the master slave, okay, QM and QM bar. Next, whenever clock is 1 here, R becomes 1, S is 0, R becomes 1 here. So it will reset. It will reset. Next, when clock is 1, S is 1, R is 0, it will set the QM output. Next, when clock is 1, R is 1, S is 0, so it will reset. QM and QM bar are complement to each other. You can see here when QM is 1, QM bar is 0. When QM is 1, QM bar is, when QM is 0, QM bar is 1. These both QM and QM bar are complementing to each other. Next, when clock becomes from 1 to 0, the content of the master here at this timing, the content of the master is transferred to the slave on the next edge of the clock pulse. You can see here QS. Okay. So next, again here you can see when the clock is changing from 1 to 0, okay, so here master is disabled, slave is enabled because of the inverter presence. So here what happens, the content of the master is 0. that is copied into the slave. When it is copied, when the clock becomes from 1 to 0. Next, check here. Whenever the clock becomes from 1 to 0, what is the content of the master here? It is 1. That 1 is copied into the slave. When it is copied, when clock becomes 1 to 0, here master is disabled, slave is enabled. So the content QM and QM bar are connected to the SR inputs of the latch. So it is 1 is there. So this data is copied into the slave here. When it is copied, when clock becomes from 1 to 0. So QS and QS bar are complement to each other. You can see here, and they are nothing but the Q and Q bar of the master slave SR flip flop. Why master slave SR flip flop? Because it contains master section and slave section also. The content of the master is copied into the slave. Whatever the master says, the slave has to do it. Okay. So whenever the clock is 1, master enabled, slave disabled. Whenever clock is 0, the content of the master is copied into the slave. When the clock becomes from 1 to 0, whatever the master says, the slave has to do it. The content of the master is copied into the slave whenever the clock becomes 1 to 0. Okay, so this is the working of a